Hello everyone, welcome to our presentation on Genesis of Complex Text to SQL Universes with Gemini Pro's Generative AI. Our team members are K. Siddharth Reddy, M. Varshit Sai, and Ramalingam Vinay. This project is done under the guidance of Dr. Y.J. Nagendra Kumar, Professor and Head of Information Technology. Coming to the abstract, this project proposes an end-to-end application that leverages the power of generative AI, a large language model like Gemini Pro, to bridge gap between natural language and database querying. Users will be able to interact with the application by providing prompts in natural language, and Gemini Pro will translate these prompts into corresponding SQL queries. This application will then execute the generated SQL query on a connected database and retrieve the desired data. This application can automate the process of translating natural language prompts into SQL queries, saving users time and effort. The application can potentially generate more accurate and efficient SQL queries compared to manual creation. It highlights the potential of generative AI for solving problems across various domains by demonstrating its application in data retrieval from relational databases. We present a novel approach for text SQL query generation, enabling users to interact with the relational database using natural language prompts. This project enhances the power of generative AI to democratize data access, and users with limited SQL expertise can now efficiently retrieve data and information from the databases. The aim of the project is to translate natural language prompts into accurate and efficient SQL queries. It also bridges the gap between natural language and database querying. It also demonstrates the potential of generative AI for solving problems across various domains. There are few existing systems already done on this work, but many of them have disadvantages, such as in the current scenario, users need to write SQL queries directly to retrieve data from database. Users need to understand the database schema and SQL syntax to formulate queries. This can be a barrier for non-technical users. Writing complex queries can be time-consuming and error-prone. This approach excludes users with limited SQL knowledge from accessing and analyzing data efficiently. And the proposed system of the work consists of users interact with the application using natural language prompts describing the desired data. The system leverages Gemini Pro, a large language model, to analyze users' prompts and translate them into corresponding SQL queries. Gemini Pro bridges the gap between the natural language and database querying by generating accurate SQL statements based on the user intent. Improved efficiency by saving time and effort compared to manual coding, and reduced error by leveraging Gemini Pro's capabilities can potentially reduce errors associated with manual SQL writing. The application connects to the database, executes the generated SQL query, and retrieves the requested data. And coming to the architecture diagram of this project, the architecture diagram of this work illustrates the robust and streamlined approach to translating natural language queries to SQL commands and retrieving data from database. The process begins with the user interacting with an generative AI application where they upload an Excel file containing the database and input their query in natural language. This initial setup is crucial as it sets the data environment and specifies the user's intent through the natural language question. The SQL query is generated by embedding model, and it is executed against the database to retrieve the necessary data. A large language model is then given this data to guarantee that it accurate and up to the date. Ultimately, the user is presented with the results by the generative AI. After receiving the processed data, the user can view the processed data in his web interface. Coming to the design phase, the first one is use case diagram. Here we can see two entities involved, user and the system. Firstly, the user inputs the Excel file which contains the database. So he uploads the data to the generative AI. This generative AI loads the text data, pre-processes the text data, and generate the SQL query from the data. The generated query hits the database. After the required data is retrieved from the database, the user can view the retrieved data in his web interface. And coming to the class diagram, the class diagram represents the project in types of components, such as the Streamlit, which we use for the web interface, and the file uploader, where the user can upload the Excel file, and the data frame processor. And it also contains a DB connection where we use SQLite 3 for database, and a Gemini LLM to convert the text to the SQL data and to retrieve the result. And this is the sequence diagram of the work. And coming to the activity diagram, it generally states the workflow of the project, such as defining the prompt, configuring the generative AI, provide the database, input the text data, and the prompt is captured by the LLM, that is Gemini Pro. The LLM processes the data, and generates the text to the SQL query. And the generated SQL query hits the database and retrieves the data from the database. And now the user can see the data. And coming to the part of the source code, the source code, initially we need to import the essential libraries for working of our project, such as Streamlit, SQLite 3 for database, and Pandas for data frame processing, and generative AI. And firstly, we need to configure the API key of the generative AI for working of the project, which is the main thing. And again, we write functions, various functions such as Gemini response. It takes the question and prompt, the question given by the user and prompt defined by the application developer, such as in parameters, which generates the text as output, which is nothing but an SQL query. And the SQL query and database is given as parameters to the another function, which retrieves the relevant data from the database. At the down, we can see the prompt. This prompt defines how the Gemini API or the Gemini Pro should work. Within case of our project, it need to convert the text given by the user to the SQL queries, and the queries need to hit the database and retrieve the relevant data from the database. So this part contains the front-end code, which is nothing but, in our case, we use the Streamlit as a front-end interface for our project. And it has the basic header and file uploader. In case of we accept only Excel files from now. After, we can improvise this project by applying various types of data. And the user uploads the data, and we can form a connection from the connection to the SQL3 database. And after user submitting the data, we can retrieve the result. Now let's show the results. After executing the code, now the user can view the interface in a Streamlit application. And this is the interface that can be displayed for the user. Here the user can input his data files. And after inputting the data files, we can see the data in the tabular format, so that we can know the data is successfully loaded into the database or not. After ensuring the data is loaded, the user can provide the input query, such as, for example, here we provided how many students are there in each branch. And after clicking the get response, in the right side, we can see that we can get the count of the students from each branch. And similarly with the case of English, we can try with other languages such as Telugu, Hindi, or Spanish, etc. For example, in Telugu, we need to get the list of students whose GPA is greater than 9.4. By after giving the input query in Telugu and after clicking the get response, we can view the result. Similar case with Hindi and Spanish. And the generated SQL query from the English text can be displayed in the terminal view of our VS Code. Thank you.